Thank you. Hello, everybody, and thank you for the invitation. I hope that we'll talk about. I will talk about cybersecurity and blockchain. And if anyone has any question, he can ask. And in the last of in the final slide, I will answer all of your questions. Okay, perfect. Okay. So my name is Souhail Mssassi. I'm a Moroccan, and I work. I'm director of Shellbox. It's a company that do pen testing and auditing of cybersecurity and also development in blockchain. I'm also an offensive security engineer at Harvard. So it's a firm that do also auditing. We do auditing of Polkadot, Avalabs, Ethereum. So very big company. And also I was working as a security consultant. So basically my job, it was to find vulnerabilities in mobile application, web application, infrastructure. So I helped a lot of companies to fix their bugs and fix their vulnerabilities. So today's talk is about blockchain security. So it's a very, very interesting topic. As a developer, of course, when you code, you should make a secure code. And also as an engineer or as a pen tester, you should look for vulnerabilities and look for some weird behavior that can lead to some unauthorized access or that can lead to some damages to the smart contracts or the company. So before to start, first, what is cybersecurity? Just to understand the importance of cybersecurity matter, or the most important thing in cybersecurity, it's data. So of course, we are now talking about, everyone is talking about data, about secure data, about privacy. So the data is the most important things for us as a persons or also as a banks, as companies. Of course, the criticality of the data or also these assets can change from entity to entity. For example, if I'm a normal person, my personal images, my personal data, it's an asset for me that I don't want any hacker to access this data. But for example, if I'm a bank, my client data or my company personal data, it's the asset. So no hacker can access this data, or for example, our reputation will be touched. So three things are important in cybersecurity. So it's confidentiality, it's integrity, and it's availability. Confidentiality, it's imagine that I talk to a person B, and for some reason there is a third person that he is listening to us. Of course, no one want to his conversation will be listened by another person. So confidentiality is some mechanism or some ways that will ensure that our communication will be secured through some cryptographic function. Also, confidentiality or cryptography, we've seen it a lot. It's a very, very old techniques. We've seen it also in World War II and World War I with the Enigma machine and with also Alan Turing. So confidentiality is very important, and we see it also in a blockchain with some mathematical function. The second thing, it's integrity. So imagine that I send a transaction, or for example, I store a file that contains some information. Integrity says that if we store something, it should be remaining the same. So of course, there is some techniques like, for example, hashing function that will ensure that our integrity it's remaining and it's stable. The third thing is availability. So availability is the way that we can say that, for example, if we ask a service from a server, we can do it. And of course, if we, for example, send a request, the server should answer us with a response. Of course, in the case of the blockchain, and of course it's decentralized, so we can say that the availability here it's existing in the blockchain. In the blockchain, we don't have the problem of the spot, the single point of failure. So okay, now we understand some points in cybersecurity. Why we are afraid, or why we should care for this cybersecurity? Of course, there is some persons that can misbehave, or there is some person that we call hackers. So hackers are some person that they have a lot of knowledge in computer security, but they have bad intentions. So either they want some reputation, they want, for example, money. So their goal is to break things and access to data and sell it to, for example, to other concurrents or in the dark web. So these hackers can misbehave and they can damage smart contracts or the reputation of the company. So we know that cybersecurity is very important. Either we have a dApp, a smart contract, or we have in general an infrastructure. But why is it important to secure our smart contracts? Is there any difference, for example, between security in blockchain and the classical security, like, for example, web security and mobile security? So these some differences, of course, between blockchain security and classical security in philosophy, and also in the way that a developer should understand the security in blockchain. And of course, there is some concepts that will lead us directly to why the security in blockchain is important. So the first concept is to what we say in cybersecurity is security by design. So what is security by design? Security by design is a mindset, or it's when a developer will develop a code, he will think from the beginning of the security of or the architecture of the application. So in the classical way, a developer will develop the code, then make some penetration testing, and for example, if he finds some vulnerabilities, he will fix them. But it takes a lot of time, it takes a lot of energy to secure your code in this way. Security by design, it's a coder with a mindset of a security guy, and he will implement security at the same time when he will develop his code. So this is the first thing. So security by design will directly lead to us that security in smart contracts is very important. The second thing is smart contracts or blockchain in general. It's a new era, new protocol, new technologies are born. So of course, new technologies directly lead to us to new vulnerabilities and new attack surfaces. Of course, if we talk about smart contracts or Ethereum, it's been 5 years or 6 years. So now the EVM machine or Solidity, now it's still very experimental. We each month we find new vulnerabilities. It can be technical vulnerabilities, or also logical vulnerabilities, like some DeFi hacks, for example. You can view also some flash loan attacks. So of course, when we have a complex system or a new system, we should adapt some really robust and solid security aspects. The second thing is that development in blockchain, and specifically with Solidity in Ethereum, require a new philosophy. So if here we are with us there is some developers in web or mobile, they will find the difference between development with Solidity and development in web. Of course, there is some similarities in syntax. Of course, Solidity, it's based on ECMAScript, so you have some similarities with JavaScript, but there is some concepts, it's like, for example, transaction, sending ether, timestamp of the block, etc. So there is some concepts that there is it's different from the classical development, and it requires the developer to understand some fundamental things and some advanced also things to implement a good security. So and the third and the last reason is just smart contracts are in general way are done to do some financial transaction, and of course as I already mentioned, hackers are looking for reputation or money, and of course there is money in smart contracts. So in cybersecurity we say that smart contracts, it's like Disneyland for hackers. So for example, if a hacker has found the vulnerabilities in smart contracts, he can drain a lot of millions of dollars from this smart contracts. And we've already seen it with the DAO attack, and also with some flash loan attack that cost a lot of money. Also, there is some differences between the classical development and the development of in blockchain. If, for example, we are in the case of a public blockchain, everything in this blockchain is public, including the transaction, including the code of the smart contracts, including the data. So even, for example, if we make a variable private, and it's a lot of developers made this mistake, they think that if, for example, we make a private variable, we can't access it, but of course we can access it and we can read it, the content of this variable, because it's stored in the blockchain. So it's just a matter of time that the hacker will search in the constructor or in the transaction, and he will decode the content of the variable. So of course in blockchain, when we, for example, store some variable, we should know that every variable, it's public and everyone can access it. So for example, if you want to store some certificates, some private keys, we should not do it in the blockchain. And of course, there is some problems also in security. So in the classical security, if the red team found a vulnerability, it's easy just to report this vulnerability to the development team, and of course they will say to fix the vulnerability, and the developer will just implement a new patch and deploy it to the web server. But in the case of the blockchain, it's not easy as that. So of course, as we know, smart contracts are immutable. So once we deploy the smart contracts, we can't change the content of these smart contracts. So imagine that if, for example, we find a bug or find a vulnerability in this smart contract, so it's not as easy as that to just deploy a new smart contract. So we should make some security patterns, some proxy patterns to solve this problem. So of course, this difference or this difficulty it's the most important things in this context of smart contracts, and of course these things or these aspects of immutability or the patch problem will force the developer to make sure that the smart contracts is secure before deployed. Now we are going to, we understand, of course, why it's very important to secure our smart contracts and why it's important to secure blockchain. Now we are going to talk about some classical attacks in blockchain. So I will talk about these vulnerabilities from two perspectives. The first perspective is that if I want to go or to search in cybersecurity in smart contracts as a pen tester, so in the offensive way, but also we will view it from the perspective of a developer. So imagine that I'm a developer, I develop in Solidity, I want to develop my smart contract in a secure way with a mindset of a security engineer. So of course, there is some layers or there is some levels of security in blockchain, and we find three levels of these weaknesses in the Ethereum case. So we have the Solidity, so the application layer. We have also the EVM machine. So for the person who don't know the EVM machine, we have three types of programming language. We have compiled language, we have interpreted language, then we have machine languages. For example, compiled languages, it's like C or C++. Interpreted language, it's Python, for example. For machine language, we can say that we have Java with the JVM, the Java Virtual Machine, but also we have Solidity with the EVM machine, Ethereum Virtual Machine. And also we have some weaknesses on the blockchain protocol. So each layer or each level, we find some vulnerabilities. And of course, as a developer, we should look in these three layers. Of course, you can secure the application layer or the Solidity part, but if we forget the EVM part and the blockchain part, it's very easy to the hacker to access your smart contract or to break your logic. So of course, in Solidity, we'll talk, of course, this talk will focus specifically in the application layer in Solidity. We have a lot of vulnerabilities in Solidity, like for example, calling some unknown address, for example, some time dependency disorder. We can talk also about some reintrinsic attacks, some secrets, or also some randomness generation. So there is a lot of vulnerabilities that we will talk about in Solidity. We have also the EVM machine part. So the EVM, in the machine itself, they have some vulnerabilities. For example, we can talk about the stack size limit. So in the EVM machine, the stack size limit is 1024 in depth. So we can call or we can fill our stack with 1024 call function. And if we surpass this number, of course, an error will be thrown and no function will be executed. The third thing is the blockchain. And of course, each developer should know this. In blockchain, there is some problem in generating randomness. Of course, the EVM machine, it's predictable, it's a deterministic machine, and it's not easy to generate a random number, a real random number. Of course, there is some mechanism and some methods to generate a pseudo number with some timestamp. We can also generate some random number through an oracle, but it's not very easy to generate a real random number in the blockchain. So now we will view some others. So the first problem we already talked about, it's keeping secrets. So of course, when we declare a private variable, it does not guarantee any confidentiality. Of course, the blockchain is public, so we can, if we can access directly to blockchain explorer, to Etherscan, we can view each transaction and view also call function. So for example, imagine that we have a smart contract and with a function, for example, called withdraw. And in this function, for example, I injected with an integer x. So of course, each person in the blockchain, he can view this transaction. He can view also the parameter of the integer that I injected inside the function. Of course, these other problems like ether loss. So imagine that if I send the ether to an orphan address, of course, all my ether are lost and are gone, and I can't get back my ether unless I find a way to break this wallet or this public address and find the private address. So here, as you see, we will view some example in some vulnerabilities. So we will view the code part. And of course, here it's a very classical vulnerability. Here we have two contracts. So we have the first contract called wallet. So here we have the wallet contract. It contains some standard things. So here we have two variable, two addresses, the address of the owner of the smart contract, and the first thing is the address of a wallet library. So the wallet library, it's another contract that will have some function. It's a library. We have also another function. So here, as you will view it, this function has the same name as the contract. So we call it a constructor. Constructor is a function. Constructor is a function. In older version of Solidity, we declare it with the same name of the contract, but now we can just make the statement or the syntax, the keyword of constructor, and it's a function that will be executed once the smart contract is deployed. So here in the constructor, we have a parameter called the owner. So here, once we will deploy the smart contract, we'll inject it with the address of the owner. It can be our address or any other address. And what here we are going to do, it's first, it's very weird. So instead of directly assign the variable address owner to this underscore owner, we are going to do it, but in a different way. So we are not letting the contract wallet that they will change the owner, but we will call another function inside another other contract that is called the wallet library. So of course here we are doing it with a delegate call, and we are calling init wallet in the contract library. So init wallet, it's a very simple function. He takes as a parameter underscore owner, and it will change the variable or the content of the owner to the underscore owner. So of course now we will say to me, what is the problem exactly? So we are just changing the content of the owner, so it's normal. The problem here is that the developer didn't know that each function in each smart contract, everybody can call it. So imagine that, for example, directly instead of course, the constructor it's executed just one time. But imagine that if a hacker called directly this function init wallet, and of course, in this function init wallet, we don't have any modifier, we don't have any condition, and the hacker will directly put his address, and directly he automatically can be the owner of the smart contract. So basically we should do some kind of verification, some kind of modifier, but also we should prevent this problem into or with the solution of directly in the constructor. So here I don't see any reason to make another call in another smart contract, but we can directly make it in the constructor or use some libraries provided by OpenZipline, for example, like Ownable, to make an owner for this smart contract. So this is the first famous problem in smart contract. So if you are a developer, you should know that every function can be called with a user directly, or also it can be called by a smart contract. The second problem, and it's a very famous problem, what we call the Reintrinsic Attack or the DAO attack. So what is exactly this problem and how it works? So the problem is inside this 4-line code. So here we have a classical DAO contract. We have a mapping. So mapping basically it's like a dictionary that we map some keys with values, and we will map an address with an integer, and this mapping it will represent the balance of the users. We have also a function called withdraw. So if you, for example, a user want to withdraw his money, we call this function with a parameter or with an integer x. So to withdraw money from a smart contract, in this context, the developer will do 3 things. So the first thing, he will verify if I have balance, and it's very logical. So we will do the verification. There is a lot of ways to do verification in Solidity. You can do it with an if statement. You can do it with a require also. So in this case, we are just making verification with an if statement. So we are verifying that our balance. So we are calling balances, the mapping balances, with the key of message.sender. So message.sender is a variable that refers to the person or the others that calls or that making the function call. And of course, the balance that message.sender will represent our balance. So we will verify that our balance is higher than the parameter x, and it's very logical. So if this condition is true, then we will send the balance or the x to the user who is calling the smart contract. And in the last line, logical, we are we send the amount or the balance to the person. So it's logical to subtract this amount from the variable or from the mapping balances message.sender. So for the first site, we see that everything it's okay, but of course here there is a critical vulnerability that we call Reintrinsic Attack, and of course it leads to fork the Ethereum to Ethereum Classic and the Ethereum that we know now. So the attack, it's a very simple attack. So here we have a schema that will represent the attack or the way how the attack it works. So here we have our DAO contract, and we have also a smart contract that is created by the hacker. So basically here the contract of the attacker, it will interact directly with the smart contract. So of course, in the smart contract of the attacker, he have 2 functions. So we have the function start attack. It's basically just calling the withdraw function that is located in the DAO contract with a parameter of 100. And also there is a second function without any name. So we call it a fallback function. And this fallback function, they will call another time the withdraw function. Basically, to explain the fallback function, it's a function we can say it, we can view it as a default function. So for example, if I call a function that they don't exist in the smart contract, directly the fallback function will be triggered and executed. Also, we can say that this fallback function is triggered or executed directly if we transfer ether to the smart contract. So imagine that we are attackers and we want to execute the attack. So the first thing is that we will call the start attack function. So basically the start attack function, as I say, they just execute the withdraw function located in the DAO contract. So the function withdraw will inject it with 100, of course, and we the smart contract will do the verification. So imagine that, for example, this smart contract have in the balance, for example, 200. So the first verification will be true, of course, because 200 is higher than 100, and the DAO contract will send ether to the smart contract of the attacker. And of course, when and I already mentioned, when we send ether to another smart contract, automatically the fallback function will be executed. So here we will execute also the fallback function, and inside the fallback function we will call another time the withdraw function. So of course, when we call another time the withdraw function, here we are not going to the last line, so we are not subtracting the 100 from the balance of the smart contract, but directly we are making another time the verification, and the balance of the smart contracts remain 200, even if the DAO contracts are already sent the 100. And of course, this attack will be remaining forever because each time that the DAO contract will send 100 to the smart contracts of the attacker, the fallback function will be triggered, and we will be executing the withdraw function with 100. And the balances of the smart contract, of the attacker smart contract, will never be zero. So each time it just keep it, it will be a constant. And of course, all the money or all the balance that is located in the DAO contract will be transferred to the contract attacker. And of course, if the balance existed in the attacker in the contract of the attacker, he can make a function, for example, called withdraw with a modifier of only owner, for example, and he can transfer to him all of the money. So here, a very interesting thing, it's called the Reintrinsic Attack. And of course, we exploit the fallback function with also some logical things in these two lines. So now we view the offensive part. So as a developer, how I can prevent this vulnerability? Of course, we should subtract the X from the balances. Then we should send our then we should send the amount or we should send ether to the smart contract. So this is a general rule, and this is also a security pattern. If we are doing some delegate call or some sending ether, it should be the last thing. So we should do the treatment, we should do the logical aspects, then we should make some delegate call and some transfer of ether. Of course, there is also other problems, like sometimes. So imagine that here we have, for example, a smart contract that represent a market. We have a seller and a buyer. So there is some function, for example, create offer, update offer, and accept offer. Imagine that a seller will create our offer that we represent, or they want to sell 10 tokens for 1 Ether, and he can also update, for example, this offer. So in the normal behavior, a seller will create an offer, so selling 10 tokens for 1 Ether. The buyer, for example, is very happy with this offer. He will accept it. And then if, for example, the seller wants to update his offer, he can do it. So there's no problem because the transaction has already been done. But imagine if the miner will switch the execution function And the order of this function, it will be create offer, then update offer, then the last thing is accept offer. So here the buyer will accept the offer of buying 1 token for 1 Ether instead of 10 tokens for 1 Ether. So here we view just to some time dependency or the order of the execution of the function. The developer should be not think that the execution or the miner will execute it in the correct way, but of course he should do some verification to make sure that this function will be executed at a certain order. Of course, there is some security patterns. So this is the last thing that I will talk about. We view it the offensive way. Now, as a developer, how I can secure my code through some best practices and some security patterns. So there is a lot of security patterns, like for example, access restriction. So in each call, I should know exactly who is authorized to make this call. And of course, when I know who is authorized, I should do some kind of verification through a modifier, through some if statements. And of course, it's very important to make this kind of restriction. There is also the second security pattern, pull over push. So the pull over push will, of course, prevent some logical problem. And instead of, for example, that the smart contract will send directly Ether to all of the users, we should make the logic of the smart contract that will force the user to make a function call to withdraw his money. And the last security pattern is the emergency stop. So imagine, for example, if we have a smart contract and we have a vulnerability or a problem in this smart contract, and of course we have a critical function, and everyone can call this critical function. For example, you can withdraw the money, etc. So if we find this bug or vulnerability and we didn't do any security pattern, we will be stopped forever. So this emergency stop, it's like an option to disable the execution of some function through some modifier. So basically, it's very simple. We should just do a modifier that will verify the state of a variable called, for example, state. So it's a Boolean variable, and of course, in the deployment of the smart contract, this variable will be false, but each function that we want to stop it, when the stopped is true, we should do or we should add this modifier stopped in emergency. And of course, we should also make a function called stop contract that we stop or change the state of the variable is stopped from false to true. And of course, each function that have this modifier stopped in emergency, even if we call it, it will not be executed. So the last thing here is some general rules. So the first thing, we should keep our contract simple. So don't write any fancy code, don't write any complex code. So the key is the simplicity. When our contract is simple, you can secure it and look for each critical part. The second thing, of course, as a developer, you will use some codes of other developers. You will use some call some libraries. You should, of course, use some tested code and audited code, because if you use a vulnerable code, your code also, or your smart contracts will be also vulnerable. Also, unit testing is very important. Each function that you make as a developer, you should make some unit testing and exactly look for some abnormal or anomalies behavior. And of course, before deploying the smart contract, as we know, smart contracts are immutable. You can do some auditing to the smart contract from firms, or also making some bug bounty program. And for example, if some persons find a vulnerability, you can reward them with the cryptocurrencies or real money. And of course, as a developer, you should know some basic things in cybersecurity in a general way, but also some security aspects in smart contracts and Solidity security, like for example, security patterns, some design patterns, and also some famous attack or some famous DeFi attack. So I finish my talk. So I hope that it's very interesting talk. Feel free if you have any question to ask. So you can ask me any question related to security in smart contracts. Thank you.
Thank you so much, Mr. Souhail. It's a very interesting topic and very important topic, to be honest. Let me check if anyone of the audience have any question. Please let me drop it in the chat box, or here in Zoom, or on the website, or unmute yourself. Feel free to unmute yourself to ask questions. I already have some questions, so I don't want to like start with my questions unless you do. We don't have questions on the website and here. Okay, I will let like 2 minutes to our audience to like think about the questions they are thinking of. My question is, if you have a recommendation or suggestion of some tools used to like check for vulnerabilities that you like love to use or just recommend it, because you know it's checking the you know, blockchain developers are like gold now, and blockchain security developers like they are so rare. So my question is, so it's like if you provide some tools that help blockchain developer find the vulnerabilities and check the codes, that will be much helpful for.
Okay, I see. I understand your question. So it's a question that all developers ask. Of course, to talk about scanning or security, there is two kinds of scanning. So there is a static analysis, or there is a static scan, and there is a dynamic analysis. So analysis or static analysis is the way that we will view the code without interaction with the smart contracts, and the dynamic analysis, it's an analysis that we will interact with the smart contracts and of course look through the workflow of the execution of the smart contracts, look for example, memory inside the EVM machine. Of course, there is a lot of tools. There is a commercial tools, and there is also some open source tools that is used by developers and also pen testers. Me as a pen tester, for example, I work with some long smart contracts, some very complex smart contracts. So the first thing is that I use some tools, for example, like solo graph, to have an idea, a general idea about the smart contract, some function or some interaction with some function, just to have a look, to have a general idea about the smart contract.
Yeah, what's public, what's private, what's the call stack for the function. So yes. I guess I used like an extension, this code extension for this as well.
Yes, exactly. And of course, it will help the developer and also the pen tester. So the pen tester, of course, it's not the person who is developing the code, so he should understand in 1 day, 2 days all the logic of the smart contract. He can't find vulnerabilities, and he don't understand the logic of the smart contract. And of course, if you are a team of developers, also SolGraph will help you to understand the logic to have a basic idea of the smart contract. So this is for visualization and to have a general understanding about the smart contract. Also,
it's open source.
Yes,
free?
Yes, okay. Yes, it's open source. We can
only Solidity, right?
Yeah, we can install it just with npm, and we just give it the Solidity file, that's all, and he will output to us a graph, and we can view all the functions.
Perfect.
But in the static and dynamic analysis, there are also a lot of tools. Like for example, I work with Metics. So Metics is a tool that will verify or will find some common security vulnerabilities, and they will verify also if this smart contract, for example, have some problems like Reintrinsic Attack, for example, like underflow or overflow attacks. There is also Slider. So Slider, it's also a framework. They do static analysis, and of course, it's written in Python, and you can also view some security bugs in your contracts. But for the dynamic analysis, we can find the Manticore. Manticore, it's a tool that support the EVM machine, and of course this Manticore will help us to debug exactly some aspects in the EVM machine. Of course, also there is some tools that is like Octopus. So Octopus and also Smart Check. So they are very helpful to developers to know exactly where is this problem. Of course, these tools that you will use as a developer, you should be aware that they will not find all of the vulnerabilities, and of course they can view what we are calling false positive. So false positive, it's the tool will say to you that it's a vulnerability, but in fact it's not a vulnerability. So you should or the developer should verify this vulnerability by viewing or by comprehending the logic behind, and also exploiting it.
It will not replace your role as a developer, the human interaction to check that the code is well written and secure.
Yes, exactly. It's just the tools will just help you to automate finding the vulnerabilities, but of course there is a logical vulnerabilities, and of course logical vulnerabilities, any tools can't find these logical vulnerabilities.
I really appreciate sharing all these tools with us. Thank you so much. I have another question, but I have one raised hand from Zakaria Hassanin, so I'll let him ask you his question, and then I'll ask you my last question for this session.
Okay. Okay. Thanks for your interesting session. I want to ask two questions. The first question is, you said that there is a function to modify a smart contract after deployment on blockchain. How is opposite of immutable of blockchain? This is the first question. Second question, who is able to assess the security for any company before full adoption of blockchain? Is IT auditor, or who is responsible for assessment of this? Thanks.
Okay, I see. The first question was about the emergency stop, right?
About yes, about the function that modifies the smart contract before after deployment on blockchain. You said that there is a function to modify a contract. Yes.
Yes, there is some patterns, some proxy patterns that they with them we can not change, but just do some fixes to the smart contract. And of course, there is some things that we can do even if we find, for example, a vulnerability or a bug, we can stop the smart contract. So, for example, I talk about the emergency stop pattern. So it's a modifier that will prevent calling some functions or prevent the execution of all the smart contracts. But imagine if we don't want to stop the execution of this function, but we want to make some updates to the smart contract. As we know, smart contracts are immutable. So how can we do some patching or how can we upgrade our smart contract, there is a pattern that is called the proxy pattern. So a proxy pattern, it's like here in networking, we know a proxy, it's an intermediate between the client and the server. So the proxy pattern will behave the same way. So we have a proxy smart contract. So client will call directly the proxy smart contract, and this proxy contract will forward your request to the smart contract where there is the logic behind. So imagine, for example, if we find a vulnerability in the smart contract directly, we can deploy a new version of our smart contract deployed to the main network. And of course, when we deploy it, we have the address of the smart contract. Then we will go to the proxy smart contract, and I will say to the proxy smart contract, instead of calling the first smart contract, here is the address, and you should change it to this smart contract, and the proxy pattern will forward all of the requests to the second smart contract. Of course, there is also other patterns. Just the proxy patterns is not an easy pattern to implement in a correct way. Of course, there is some problems in storage, in the way how users will adapt to this logic. So there is a lot of problem of the proxy pattern, but developers should know this pattern, this interesting pattern, and also should know the emergency pattern. So this is for your first question. The second question: who is responsible for the blockchain security or to audit smart contracts? Here it depends. So it depends in the entity or in the company or the persons who are making or developing the smart contract. So in a perfect world, basically you want the developer to implement security by design. So to implement security in the first line of code. But when the developer will deploy or will develop the first, for example, beta version, so before deploy it, you can have two things. So either you have an internal team that will do auditing or pen testing, or you can call other companies to do pen testing of the smart contracts and also certify that this smart contracts have been audited. So, for example, if we or if the smart contracts we find vulnerabilities in the smart contract, directly we will report it to the developer or to the CISO, and of course the developers will fix these bugs and fix these vulnerabilities, and they will another time they will give the new code to the pen tester to make a counter audit, so to view that the recommendation or the vulnerabilities found have been fixed and have been implemented the secure things to prevent the vulnerabilities. So it depends on the company or the entity, how from little companies to bigger companies. There is some persons that they deploy directly without auditing, and there is some critical infrastructure that they need some very professional companies to make for them audits. I hope that I answer your question.
Yes, it's okay. Thanks for your. I want to LinkedIn profile or a way to communicate with you.
Okay, you can talk with me through email or LinkedIn. I mentioned it in the last slide. You can view the slides, right?
Yes, we can see it. And if you left your LinkedIn or social accounts on your profile on the Hova platform, all our audience who attended the session and watch it as a record later on can contact you if they have any question, want to say thank you for you and for your time. That will be much appreciated. Okay, yeah, this is the end of the session, but we don't have a session after that. So if anyone wants like ask any question, we still have, we can like extend for 5 minutes if Mr. Souhail doesn't have any time engagement or so. Anyone has a question? My last question, I'm sorry to take a lot of time, but you know, I'm a developer, so I have lots of questions in this regards. I'm just wondering if there is a kind of vulnerabilities only for blockchain smart contract or blockchain project in general, technology. I know blockchain inherits the vulnerabilities, security vulnerabilities on the classical in the Web 2 world. And in Web3, we have a new type of vulnerabilities. If you just mention part of it, if there is, that would be much appreciated. And this is my last question.
So your question is basically, there is any vulnerabilities that we find in the classical vulnerabilities?
No, the new vulnerabilities, it's not only in the Web3 technology in general. That's
okay.
not exist before.
Okay, I see. So of course, there is some new vulnerabilities related to DeFi attacks, and also some vulnerabilities related to Web3. Of course, there is some vulnerabilities, as you already mentioned, that we find in web application and mobile application that also inherited from smart contracts. We can talk, for example, about also overflow and underflow attack. So the underflow, we find it also in some desktop application, but also in the smart contract applications. But some vulnerabilities, that is the new vulnerabilities now that we are finding in smart contracts are DeFi hacks and of course logical hacks. For example, I can mention flash loan attacks. So flash loan attacks, they are really interesting attacks that we find in smart contract, but it's for the tools that I already mentioned. These tools can't find this kind of vulnerabilities because it's a logical bugs, and it's very difficult to find it. For the Web3 problems or Web3 vulnerabilities, of course, because it depends also if we use JavaScript or Python with the library Web3.py. And of course, new versions now, we can see in each commit of Web3, we find a lot of interesting vulnerabilities. My advice is just to use the last version of Web3 to communicate with the smart contract. But we also, if we use Web3 with the context of JavaScript directly, we will find some interesting problem in JavaScript and Web3. We can find also some ways to get access or to some private keys of the wallet. We can also find some problems that will force the user, for example, to make some transaction just with clicking through or just with one click. So of course there is a lot of problems. And of course, I can give you some resources, some repo Git to explore more vulnerabilities. Of course, these vulnerabilities that I already mentioned is just we can say it's the top of the iceberg. But of course, there is a lot of vulnerabilities in smart contract, dApp, and Web3 that I can talk. That I cannot say it all of these vulnerabilities in this talk. But I will send to the organizer, or I will mention in the whole application some resources that if you want, for example, to focus more in the security part, you can go for it and play some challenges and look for new concepts.
Yeah, much appreciated. Thank you so much, Mr. Souhail, for your time, for this amazing session. If anyone has a question, please ask before we end this session.
Yes, I have another question, last question. I want to ask about the risk in general. Who will assess the risk in general? Is there a team from different background, including security team, or just security person who will able to assess all the risks in blockchain, including smart contract risks?
Okay, so for risk assessment, not the security persons that will risk or assess the risks. So it's the IT person, so it can have some knowledge in ISO 271, 2007 to 275 also. So I have some knowledge in some regulation, but also the core of the team will assess the risks. For example, for some missions that I pen test, some functions or some problems that I found in some smart contracts, only the client will understand exactly what is the problem here. Of course, the IT person, he has some technical background and he has some technical knowledge, but for the logical execution of the logical flow of the smart contracts, only the client will understand it and will assess the risk and will know exactly what is the problem. So in general, who will assess the risk is the client with the help of the security team.
Okay, thanks.
Thank you so much, Mr. Souhail, for your time and for your amazing session. Lots of amazing information. Dear audience, I would love to thank again Mr. Souhail, Director General at Shellbox, and he was talking about the security of smart contract and dApps.